video is about multiplying matrices. To multiply two matrices together, the number of columns in matrix A must equal the number of rows in matrix B. This is very specific and very important. You count the number of columns in the first matrix, which here is 2, and the number of rows in the second matrix, which here is only 1. And if those two numbers are not equal, you cannot multiply the two matrices together. It is not possible to find the product of this matrix times the second matrix. Let's try it in example 2. We're going to count the columns. I count 1, 2 columns. I count 1, 2 rows. This one is possible to multiply. Second one I'm going to count, or the third example here, I'm going to count 2 columns. I only count 1 row. This one is not possible. And the order matters for this as well. So it definitely has to be the columns of the first matrix matching the rows of the second matrix. You cannot switch the order on that. So how do we do it if it is possible? We're going to, in this example, we're going to find the product of A times B, and again, the order does matter, if A is that 2 by 2 matrix and B is this other 2 by 2 matrix. Now they both have, or the first one has 2 columns and the second one has 2 rows. Therefore, I can find this product. So I'm going to write down my matrix A right next to, this is how I find a product, my matrix B. Okay, and I'm going to set up a 2 by 2 matrix where my answer goes. I'm going to make it a little bit big because I want to show some work in there for how I'm obtaining it. It is not as simple as just multiplying -3 times 5 and having that go in my answer. Okay, so it's very different from adding and subtracting matrices, so pay very close attention. I'm going to start by taking the entire first row of column A, of matrix A, and multiplying it by the entire first column and add the results together. That's going to go in the first spot in my answer matrix. So I'm going to take -3, multiply it by 5, and to that I'm going to add +2 multiplied by 4. The result of that all together is the first element of my answer matrix. I'm going to continue by doing the same row. I'm going to use the first row again, but this time multiply it by the second column of the second matrix. So I'm going to take that -3 again, this time multiply it by 1. -3 times 1. Go through the row, I'm going to do 2 times 6. And there's the next element of my answer matrix. And you can probably guess what I'm going to do next. I'm going to go back to my first matrix. Now I'm going to do the second row. I'm going to take this row, reset this matrix over here, and now we're going to do this first column again. Second row by first column this time, and add the results together. So -1 times 5 plus add the result of 3 times 4. And then there's only one more combination I have to do, and that's to repeat that second row, this time by the second column. So -1 times 1 plus +3 times 6. There is a pattern to it. It seems very complicated at first. After you've done a few, you'll get used to the pattern and it'll go much more smoothly. But in the meantime, you can use those arrows and follow that direction. You want to do first row by first column, first row by second column. Then move down. Second row by first column, second row by second column. Now in my answer matrix, I want to simplify all of this. It simplifies exactly the way you can expect it to. So we're going to do -3 times 5 is -15, plus 8 is -7. -3 times 1 is -3, plus 12 is 9. -1 times 5 is 5, plus 12 is 17. Oh, no, that's a -5 plus 12, that would be 7. And -1 times 1 is -1, plus 18 is 17. And that is the resulting 2 by 2 matrix from multiplying A times B. Okay, let's try another one. Always start by counting the columns of the first and the rows of the second. The columns of A, there are 2. The rows of B, there are 2. Therefore, I can find the product AB. It doesn't necessarily mean I can find BA, but I can definitely find A, B, which is what it's asking me to find. So I will write these two matrices touching side by side. And set up my answer matrix. Okay, I'm going to start with row 1 from the first matrix, and it's going to go first to column 1. So I'm going to do -1 times 3, add it to 2 times -2. I better move this bracket over. I need a little more room here. And I'm going to do the same row by the next column. -1 times 2 plus 2 times -1. Now I'm ready to move down to my next row in my first matrix and my next row in my answer matrix as well. So I'm going to move down to the next row, which is -3 and 0, and repeat. Do it by the first column. I've got -3 times 3 plus 0 times -2. Then run it through second row here through the second column. -3 times 2 plus 0 times -1. And I'm ready to move on to the third row in my first matrix and in my answer matrix. So my third row by my first column, -4 times 3 plus 1 times -2. And switch to green. I'm going to do the third row by the second column, -4 times 2 plus 1 times -1. And if you notice in my matrix, my answer here, in all the parentheses, I end up with the same thing because I'm constantly running it through the second matrix. So you'll notice I have a 3, -2, a 3, a -2, and a 3, and a -2, all in the red, and I have a 2 and a -1, a 2 and a -1, a 2 and a -1, all in the green, because I'm constantly running it through the second matrix. Let's simplify this answer. -1 times 3 is -3 minus 4. -1 times 2 is -2 minus 2. -3 times 3 is -9 plus nothing. And -6 plus nothing. -4 times 3 is -12 minus 2. And -4 times 2 is -8 minus 1. And if you count here in our final answer, it's remember we do rows by columns to say what our matrix dimensions are. So this one has 3 rows. It has 2 columns. So our final answer was a 3 by 2 matrix. And if you look back at the original, it's going to be the same number of rows as the first matrix and the same number of columns as the second matrix. So A, which had 3 rows, and B, which had 2 columns, tells us that our answer will be a 3 by 2 matrix. So if you're trying to set up your answer matrix and you don't know how much room to leave, you can always do that little mental calculation to figure out what is your answer matrix going to look like. Okay? And that is all.